welcome back to the whiteboard, Fenrir. Let us do this again.
Thanks, Erica. All right, no fluff today. Let us cut straight to what matters. Misconfigurations do not announce themselves. They sit quietly until an attacker finds them. At cloud scale, you do not lose a server, you lose over 100 million customer records. That is Capital One 2019, and we get there in Scene 6.
Secure provisioning is about building security in from the start. Before a system goes live, it should be hardened against the threats it will face. The configuration baseline is your contract with every deployed system. This is the minimum security state required.
Hey everyone, I am Beth, joining the team today. I look at every concept through the lens of strategy, trade-offs, ownership, and consequences. If you have ever felt overwhelmed by the number of security settings that exist for any given system, this is the video where that feeling starts to make sense. Configuration baselines and hardening guides do the heavy lifting. You do not need to invent security from scratch for every deployment.
Secure provisioning connects to everything we covered in handling requirements. Once you know the classification of a system or dataset, the provisioning requirements follow. A system handling restricted data gets provisioned differently than one handling public data.
The exam will test configuration baselines, hardening standards, change management, and cloud-specific provisioning failures. Every topic in this scene traces back to the same root cause. Organizations do not apply security at provisioning time, they bolt it on after.
And wait until Scene 5, when we get into change management, because the real world versus exam view on change management is one of the most interesting gaps in this entire domain. The exam wants clean process. Real organizations do not always follow it.
By the end of this video, you will apply CIS benchmarks and STIGs, explain golden images and infrastructure as code, map cloud provisioning risks to the shared responsibility model, and analyze the Capital One breach as a provisioning failure case study.
Quick intros before we jump in.
I am excited to watch this one unfold. I will jump in when I cannot help myself.
Hey, I'm Liam. I came in skeptical, but now I am genuinely fascinated.
All right, let us jump in.
A configuration baseline is the agreed minimum security state for a system type. Every Windows server in your environment, every Linux host, every network device, each has a baseline that defines what security settings must be present before that system is considered ready for production.
CIS benchmarks are the most widely used set of hardening guides in commercial environments. The Center for Internet Security produces consensus-based benchmarks for over 100 technologies, key operating systems, cloud platforms, containers, applications. 2 levels. Level 1 is essential settings, Level 2 adds defense, in-depth controls.
STIGs, Security Technical Implementation Guides, are the DoD equivalent, Fenrir. Published by DISA and mandatory for government systems, STIGs are more prescriptive than CS benchmarks. For federal environments and government contractors, STIG compliance is a contract requirement.
Configuration drift is the problem that makes baselines a continuous practice rather than a one-time event. Systems that pass a baseline check at provisioning gradually accumulate changes, patches, software installs, manual fixes that push them away from the secure baseline. Without monitoring, drift becomes invisible.
Drift monitoring is the countermeasure, file integrity monitoring tools, configuration management databases, automated compliance scanning. The goal is detecting and remediating drift before an attacker exploits the gap. A misconfigured service running for 6 months is 6 months of attack surface.
For the exam, know the difference between CS benchmarks and STIGs. CS is industry, consensus, and broadly applicable. STIGs are mandatory for federal systems. Both produce configuration baselines, but the enforcement context is different.
Golden images take the baseline concept one step further. Instead of defining a list of required settings and hoping every administrator applies them correctly, you create a pre-hardened image that is the baseline. Every new deployment starts from that known, good state.
The golden image is maintained like software, tested, updated, and versioned. When a new vulnerability is discovered, you patch the golden image and redeploy. This is more reliable than manually patching individual systems because you know exactly what configuration the baseline contains.
Infrastructure as code is the evolution beyond golden images. Infrastructure as code tools like Terraform, AWS CloudFormation, Ansible define infrastructure in declarative code files. You describe the desired state, network configuration, security groups, instance types, identity and access management roles, and the tool enforces it.
The security benefit of infrastructure as code that the exam tests is peer review and version control, LIAM. Infrastructure code lives in a code repository, gets reviewed before deployment, and changes are tracked with full history. That review process catches misconfigurations before they hit production.
Infrastructure as code connects directly to change management. Every infrastructure change goes through the same review and approval process as a code change. You cannot spin up an unreviewed cloud instance or add a permissive security group rule without it appearing in a pull request that can be audited.
The Capital One breach would not have been possible if every web application firewall configuration change had to pass a code review before deployment. When you can click through a web console and change a security setting in seconds with no review, you have eliminated a critical control. Infrastructure as code exists to prevent that.
Cloud provisioning changes the provisioning landscape in one critical way: the speed and scale of deployment far outpaces traditional manual hardening. You can provision 1,000 misconfigured instances in the time it would take to manually configure one correctly. Speed without automation equals risk at scale.
The shared responsibility model is the framework for understanding who secures what in cloud environments. AWS, Azure, and Google Cloud secure the physical infrastructure, hypervisors, and managed service layers. The customer is responsible for everything they configure: instances, security groups, identity and access management policies, storage permissions.
The model shifts based on the service type. With infrastructure as a service, the customer owns the operating system, applications, data, and all configurations above the hypervisor. With platform as a service, the provider manages the runtime and middleware. With software as a service, the customer mainly manages data and user access configuration.
Gartner estimated that through 2025, 99% of cloud security failures would be the customer's fault. Not provider failures, customer misconfigurations. OpenS3 buckets, over-permissive identity and access management roles, security groups that allow 0, 0, 0, 0 on every port. Those are provisioning failures.
Cloud Security Posture Management, CSPM, is the technical control that addresses this at scale. CSPM tools continuously scan cloud configurations against security benchmarks and alert on deviations. They are the automated drift detection mechanism for cloud environments.
For the exam, know the shared responsibility boundaries for infrastructure as a service, platform as a service, and software as a service. Know that most cloud breaches result from customer misconfiguration, not provider failure. And know that CSPM is the category of control that monitors cloud configurations for compliance.
Change management is the governance layer that sits on top of provisioning. It requires that every change to a system new deployments, configuration updates, software installs, goes through a formal approval process before it is implemented. Unauthorized changes are the source of most misconfigurations.
The request for change RFC is the formal document that initiates a change. It captures what is being changed, why, what the impact assessment says, who tested it, what the rollback plan is, and who approved it. The RFC is the audit trail for every infrastructure change.
The Change Advisory Board is the review body for significant changes (LIAM). The CIB includes representatives from IT, security, operations, and affected business units. They assess risk, verify testing, approve or defer. High-risk changes may require board approval and scheduled maintenance windows.
Emergency change procedures exist for critical security patches or incident response. They allow a faster track, sometimes just one approver instead of full CIB review, but require post-implementation documentation and review. Speed is allowed, documentation is not waived.
The exam tests the difference between three change types. Standard changes are pre-approved, low-risk, recurring. Normal changes go through the full RFC and CIB process. Emergency changes are expedited with post-implementation review.
Drop in the comments, does your organization actually enforce change management for cloud configurations, or is the cloud treated as a free fire zone where anyone can spin up resources without review?
I want to push back a bit. The exam presents change management as this clean, formal process. In real organizations, pressure to move fast means emergency change procedures get used for non-emergencies. The process exists on paper, but culture undermines it.
That is a real tension worth naming. The exam tests whether you know the correct process, RFC, CIB, 3 change types. For the exam, give the correct process answer. In your career, work to make the process fast enough that people stop routing around it. A change management process people bypass is not a control. It is a speed bump with exceptions.
Capital One 2019 is the gold standard case study for cloud provisioning failure. A security researcher discovered a misconfigured web application firewall on Capital One's AWS infrastructure. That web application firewall was supposed to filter malicious requests. Instead, it was configured to forward them to internal services.
The attack technique was server-side request forgery, server-side request forgery. The attacker sent a crafted HTTP request that, instead of being blocked by the web application firewall, was forwarded to the AWS instance metadata service. That internal service returns credentials for the identity and access management role attached to the instance, never intended to be externally accessible.
With the identity and access management role credentials, the attacker had the same cloud permissions as the Capital One application. Those permissions included access to S3 buckets containing over 100 million customer records, names, addresses, credit scores, social security numbers. All of it exposed through a single configuration error.
The human side of this, Erica, it is easy to assume only a careless engineer could make that mistake. But web application firewall configuration is genuinely complex. The point is not negligence. The point is that no review process caught it before deployment. That is the provisioning control failure.
Capital One settled for $190 million in 2022. The technical fixes included requiring IMDS v2 for metadata service access, which uses session-oriented requests that server-side request forgery cannot abuse, and implementing least privilege identity and access management policies that limit what roles can access.
The lesson for the exam, and for practice cloud provisioning security, requires configuration review before deployment, automated compliance monitoring after deployment, and least privilege identity and access management from day one. A web application firewall that passes no traffic is secure. One that passes the wrong traffic is worse than useless.
Remember this one: the shared responsibility model means Capital One was responsible for their web application firewall configuration, not AWS. AWS's infrastructure was not breached. The customer's cloud configuration was. That distinction is load-bearing for the exam.
Let us lock in the exam relevant pieces from today. Configuration baselines, no CIS benchmarks for commercial environments, and STIGs for government. Both define minimum security configurations for system types. Both address configuration drift as a continuous concern.
Golden images enforce baselines at deployment time. Every new instance starts from a known, good pre-hardened state. Infrastructure as code adds review, version control, an audit trail to every configuration change. Together they eliminate the manual hardening gap.
On cloud provisioning, the shared responsibility model is the exam framework. Customer owns their configurations in every service model: infrastructure as a service, platform as a service, software as a service. The degree of customer responsibility decreases as you move from infrastructure as a service to software as a service, but configuration security never fully transfers to the provider.
Change management is the governance layer, RFC CISB, standard versus normal versus emergency change types. The exam may describe a scenario and ask whether a change was handled correctly. If there was no RFC and no approval, that is a change management failure, regardless of whether the change itself was beneficial.
On the Capital One case, the attack chain is the exam testable piece. Misconfigured web application firewall enabled server-side request forgery to the metadata service. Metadata service returned identity and access management credentials. Those credentials accessed S3 buckets with over 100 million customer records. The shared responsibility model places all of that on Capital One, not AWS. AWS platform functioned correctly. The customer's configuration did not.
Next video is CISSP 2.4, Managing the Data Lifecycle. We go from provisioning new resources to managing data through its full lifecycle: create, store, use, share, archive, destroy. Keep the momentum going. And subscribe so you do not miss an episode.
Okay, it is quiz time. Let's find out what's stuck. Think through each question carefully before you answer.
If you are getting real value from this series, show it with a like and a subscribe. We read every single comment.
A security team wants to ensure every new cloud instance deploys with the approved security configuration automatically. Which approach best addresses this requirement? The correct answer is A. Golden images, 2 pre-hardened templates that serve as the baseline for all new deployments.
In the Capital One 2019 breach, which attack technique allowed the attacker to obtain AWS identity and access management credentials from the cloud instance metadata service? The correct answer is D. Server-side request forgery S. Server-side request forgery through a misconfigured web application firewall.
An organization's infrastructure as a service cloud provider experiences a physical data center failure. Under the shared responsibility model, which party is responsible for recovering the customer's application and data? The correct answer is C. The customer, who is responsible for application availability and data recovery in infrastructure as a service environments.
Strong performance on the quiz. Provisioning security is one of those areas where doing it right up front saves enormous pain later. Capital One spent $190 million learning that lesson. You just learned it in under 20 minutes. Watch the 6 out there.
Configuration baselines, golden images, infrastructure as code, change management, cloud shared responsibility. These are the 5 pillars of secure provisioning. They all connect to the classification work we did in 2.1 and the handling requirements in 2.2.
Next video is CISSP 2.4, Managing the Data Lifecycle. We walk through every phase: create, store, use, share, archive, destroy, and tie each phase to the controls that protect data at that stage. Keep going. You are making real progress.
Subscribe if this series is supporting your CISSP prep. The more people find this content, the more we can build it out. Keep connecting the dots. See you next time.
Do not take anything at face value. See you next time.
I have to admit, Fenrir made that look easy. Solid 9 out of 10. Professor Erica signing off.